thing. Okay. Now we're going to skip this middle part because this is kind of a review from last unit, and I have too much stuff to talk to you about to review this. Okay, so we're just going to skip that part because it's just reviewing what we learned last time. Okay, so let's just hop into the actual part of COP, constant of proportionality. Okay, it's when the value of the ratio of two proportional quantities. Quantity is just a fancy word for number. Okay, it's represented by the equation K equals Y over X. Okay, this is super important as we lead into the part that gets you ready for 8th grade. If for some reason we do have the STAR test, you will not have to have that formula memorized. Okay, that is going to be on your formula chart. It says constant of proportionality, K equals Y over X. Okay, the thing that people get, I agree, Jackson. The thing that confuses people the most is they want to switch and put X over Y, but you just have to remember it's Y over X. Okay, if you want to write it bigger, Y has to go on top. It's opposite of what you would think would make sense. Okay, all right, so here is a table, and again, we already said COPs or COPs put people inside, so we're looking at our inside numbers, which all you know right now is inside. In a few minutes, we'll look at outside. Okay, so we're looking at the numbers that are inside our chart. Normally, they never give you this third column. It just looks like this. Okay, but the book is helping you kind of think, so it gives you a place to put it. Okay, so when we're finding constant of proportionality, all you're doing is putting Y over X and dividing to see if they're the same all the way down. Okay, so Y is 12. X is 1. Okay. What is 12 over 1 equal?
12.
12. Good. Okay. On the next one, 24 over 2 is going to equal what?
12.
12. Good. I see a pattern. 36 over 3 is, oh, sorry, I put 24. My bad. 12. Yep. 48 over 4? 12. 60 over 5? 12. Now, hopefully you didn't need a calculator for that because those are kind of some of the basics that you've been knowing. But if you did, it is okay. Okay, I don't want you to sit and struggle with the multiplying and dividing. I need you using a calculator so we can practice the skill because next year you're going to get a calculator anyway. Okay. So how do we know that the number of feet is proportional? How do you know if something is proportional?
Equal.
Yeah, the ratios are equal. Okay. What happened to all of these numbers?
They're equal.
They're all equal because they all did what?
Simple.
They all simplified. Yeah, thank you. Yeah, they all simplified to the same number, which in this case was 12. Okay, so when you have your ratios, if they all simplify to the same thing, then it is proportional. Okay. So if we know X, how could we figure out Y?
Dividing.
So if you know X, you divided to get Y? If I know X, how am I getting Y? How did I get from 3 to 36? Multiple. We're getting bigger because we're multiplying. So if you know, the whole point of this is to help you write an equation so you can plug it in and then multiply. Okay, so you would multiply X by 12. So if I want to know 100 feet, I would just say 100 times 12. Instead of going through and making this chart and skip counting, you would just use the equation to write and then you would multiply. Okay. Again, nothing too crazy, nothing hard. The biggest thing to remember is that Y has to go on top. Okay? Everybody okay on this first page? Okay, go ahead and turn to the next page. All right, Jason, you don't have your notes either? What? You should have told me. Did I just close the meat? Somehow I pushed a button on here and I closed the meat. Ah! Sorry.
I don't have mine either. I'm reading it on the paper.
On some paper? Okay. I'm going to print real quick because this is going to be a lot, and it's a lot of graphs and stuff for you to have to write if you don't have them. Basically, I'm printing 2 copies. Go over there and grab them real quick. Sorry, guys. I pushed a button. I pushed a button on my mouse, and apparently it turned it off. So, I'm sorry. I'm back now. All right. So we're on this second page. Oh, you can hear me? That's weird. Okay, I'm going to push that button. Okay. So when we are talking about the K and the Y and the X, we need to know what all those letters mean. Okay. So the Y is just going to be the Y values. So when you have tables, sometimes they're short and long. Sometimes they're tall. Okay. So your Y values, sometimes they label them and sometimes they don't. Okay. Your Y values are going to be either the bottom or the second. Okay. Your Y values will either be the bottom or the second column. Okay. X always comes first. Okay? When you have a coordinate grid, which we talked about, I know a long time. Okay, Colton, that's fine. We talked about a long time ago before Thanksgiving break. Your Y's are the ones up and down. That's your Y axis. Okay. So those are your Y values. So obviously the X is going to be the other direction. Okay, your X values will be the numbers on top. And then if it's a long one, it's going to be your first set of numbers. And then obviously on a coordinate grid, it's going to be the ones that are horizontal. Okay. Again, most of the time they will label it, but I know sometimes they don't. And I know in 8th grade, a lot of times they don't. So you just got to know. Y is bottom, bottom, up. X is top, first, and horizontal. All right. Am I going too fast or are we doing okay? Good? Okay, thank you. All right. So now we want to find, K is going to be our constant of proportionality. You actually learned this in 6th grade. In 6th grade, they used the letter A. Proportionality. In 6th grade, they used the letter A. In 7th grade, they used the letter K. And then in 8th grade, you're going to change it to M. But they're all the same thing. So if it looks familiar, you have seen it. It was just using the letter A in 6th grade. Okay? All right. So, again, some of these are good questions, but not really helpful for what we need to do right now. So we're only going to answer question 3. Okay? What is the constant of proportionality? Okay? COP. COPs put people where? Inside. So this is your reminder. COPs, inside. Look at the inside numbers. Okay? So remember our equation is y over x. So you have to think backwards. It's not this over this, okay? If it's not labeled, it's probably a good idea to go ahead and label your 2 columns. That way you don't get confused. Okay, your rows, sorry, x and y. So I'm looking inside. So all I'm doing is taking these numbers, 117 over 1. Well, that equals 117. Okay, is that something, Colton, that I need to do? Do I need to turn the captions on? Everybody else can hear me, right? Oh, okay. All right. So the next one is going to be 234 over 2. And again, this is where having your calculator is going to come in handy. So I'm going to go ahead and divide 234 by 2. What do you get?
117.
117. Okay. Remember, our goal is to try to have all of our ratios be the same. Okay. 351 over 3. Guess what? It's 117. 468 over 4 is 117. 585 over 5, 117. Okay, that is what you want to happen. Okay, you want them to all equal the same thing. Okay, so there is a constant of proportionality, a COP, and it's 117. So you have to actually divide it to figure out what the COP is. Okay, I appreciate those of y'all who typed in there. Thank you. I just now saw that. All right. I'm going to see if you are ready to try these 3 by yourself, okay? It gives you the little space to do your y over x. I want you to check to see if these are all proportional, okay? So I'm going to give you a couple of minutes. Go through and check. It has to be true all the way down. One of them might be different, so check all of them, and then if they are the same, that's what it's going to be right here where k is, okay? Give y'all just a quick second. Go ahead and multiply that for me, or divide. If you're not sure what to do, go ahead and ask. If you're sure what to do, then go ahead and check that COP for me. And if you don't have a calculator, you can use your phone or you can use one on the computer. All right, when you finish, you can check to see if you got the same answers that I did. If you have a question, let me know. Okay, so the first one was 4. The second one was 1.5. And the last one was 12. Okay, everybody feel okay about COPs? Yeah? All right, we're going to turn over to page 28. Okay, and now we're going to talk about proportionality in tables. We are going to talk about rocks. Okay, remember I said rocks are found outside. Now, when you think about a rock, can you add rocks to your collection? Yes. Can you take some rocks and throw them away? Yes. Can a boy rock and a girl rock get together and multiply and have little baby rocks? No. Okay, can I take a rock and just break it into pieces? Probably not. Okay, so you have to remember that rocks are only added or subtracted. Okay, and if you get confused, just think, wait, Miss Davis said rocks can't multiply. Okay, so rocks are only being added or subtracted, and we're looking at our outside. Okay, this is going to be very, very important. If you have a rock, that means it's linear. Okay, linear, what do y'all think that means? What word do you see? Line. Okay, if it is rocks, if it has a rock, it's linear, which means it makes a straight line. Okay. All right. So relationships are proportional if they have a constant rate of change, represented by y equals kx. So basically, once you figure out k, which we just got through learning how to do, all you have to do is multiply it by x to figure out y. Okay. So on this one, we're missing some information, but here we have 825 over 3. Okay. So what is 825 divided by 3? Use your calculators.
2.75.
Thank you. 2.75. Okay. Let's do the other one that we have, 5 and 13.75. So divide those for me. Remember, y goes on top. What do you get when you divide? 2.75. Okay, so these have 2.75. So I want all of these to have 2.75. So we just multiply 2.75 by x. Okay. So the first one's easy. Okay, this is your x, remember. Your x is the first column. Okay. So all I'm doing is doing this times 2.75. So how much would 2 cups of coffee cost?
5.5.
Good. So money is 5.50. How much would 4 cups cost? Four cups would be $11. And then how much would 6 cups cost?
$16.50.
Good, thank you. $16.50. Okay. So you're figuring out the proportion, the K, and then you're just multiplying by X. Okay. So over here at Houndstooth Coffee, 560 divided by 2 is 2.8. Good, thank you. 2.80. Okay, the other one I have is 1680 divided by 6.
$10.80.
Okay. So what do you think my K is? K is 2.80 because we just divided all that. Okay. So I want this to be 280 all the way down because it has to be the same. And now, just like over here, I multiply by 275 instead of 280. Okay. So the first one's easy because that's just 280. How much would 3 cups cost?
$8.40.
Okay, thank you. How much would 4 cups cost?
$11.20.
Okay, $11.20. And then 5 would cost $14. Okay. So again, once you figure out K, all you have to do is multiply by X. That's it. On a test, you will not have to fill in a table. So if you're a little confused, don't worry, you won't have to do that on a test. Okay, now come down here to Sumptown Coffee, and I want you to do the y over x. I'll give you about a minute. Use your calculator. It shouldn't take long if you're using your calculator. As you checked even the first two, what did you notice that was different?
The total cost?
Okay, so on these, it was $275. These were $280. But what did you notice was different this time? Did you have a constant? Was it the same? No. Okay, so here there is no cop. Okay, so there's no cop, which means it is non-proportional. Okay, when we divided them, they all equaled different random things. Okay, so it's not proportional. Sometimes that will happen. In a couple of days, we'll give you a lot of more non-proportional, but for today, I'm trying to give you proportional ones, so you get used to those. Okay. All right, go ahead and turn to the last page. And I want you to see if the first three questions are proportional. Okay, I'm going to give you about 3 minutes. You want to check all of them. I will tell you they are not all proportional. So if you get all yeses, you have something wrong. Okay, so check those 3 problems. Yes, sir.
On the first one,
Uh-huh.
3.4.
Yes, that is correct, James. Clint, yeah, that's perfect. So on the first one, they all simplify to 3.4. So this one is proportional. Okay, they all simplify to 3.4. So the cop would be 3.4. Okay. On the second one, 3 over 1 did not equal 9 over 4. So I didn't have to go very far to figure out that that one is non-proportional. Okay, that one, it didn't work out when I simplified. I didn't need to keep checking because I already proved that it was wrong. And then the last one was pretty easy. You could do that in your head probably, but I wrote it out so you could understand where the numbers came from. 18 over 3, 6. 30 over 5, 6. 42 over 7, 6. 54 over 9, 6. So this one was proportional. Okay? Everybody okay with that? Pretty easy? Okay. Now sometimes they like to put a fraction in here. Okay? So we're just doing an example to show you that sometimes there will be fractions, and also I'll show you how to do that on a calculator. Okay? So remember x is on top, y is on bottom. Our formula is the other way, y over x. Okay. So 1/3 over 1. Okay? And you might be like, how the heck do I put that in a calculator? Okay? If you have a fraction and you have a calculator, you need to put it in parentheses. So the parentheses are above the 8 and the 9 if you're here in person using a calculator. If you're on the phone, I don't remember where the parentheses are. If you don't see the parentheses, you can turn your phone sideways, and it gives you more options on iPhones. I don't know about other phones. Okay? So parentheses, 1 divided by 3 divided by 1. 0.333 repeating. Okay? The next one is 2/3 divided by 2. So I'm going to do the same thing. Parentheses, 1 divided by 3. 2 divided by 3. Close parentheses divided by 2. And I got 0.3333 repeating. Okay? We're not going to do all of them. I just wanted to show you, for one, how to put some fractions into a calculator, but also that it can be repeating. Okay? Everybody okay with repeating fractions? All right, I'm going to have you do 2 more by yourself. Okay? We're not going to do all 4 of these for time's sake. So the first one, I need to give you some numbers. 4 and 7. And then the other side is going to be 6 and 60. So go ahead and write these numbers down. And then we're going to do the third one. 5, 10, 20, 16. Okay. All right, I'm going to give you just a couple of minutes. I want you to find the COP, okay? Find the COP, find the y over x. When you're finished, you can look at the screen to see if you got them correct. If you got them wrong, make sure that you didn't flip the x and the y, because that's, again, the most common mistake is people switch the x and the y. So hopefully on that first one you got 6. I divided all these and got 6. On the other one, they all simplified to 4/5, but if you turned it into a decimal, 0.80 is also okay. Okay, so either 4/5 or 0.80 or 0.8 even. Okay. Are there any questions on COP? No? Okay. Again, remember, sometimes it is, but we also saw examples up here where it's not. So I don't want you to think it's always proportional, okay? We are going to do just 3 quick examples on rock, and then I'm going to let you get started on your assignment. We're doing good on time, okay? If you'll go back to page 25, it's a blank page. We're going to do a couple of rock examples, and then I'll let you get started on your assignment, okay? So go back to 25. It should be blank. And we're going to do just a quick couple of rock examples. So we got to draw some tables. So we have 1 and 175, 2 and 250, 4 and 400, and 7 and 625. Which column is going to be this first column? What is this called?
X.
The X. Thank you, Jamie. X. And that means this one's going to be the Y. Okay. So rock is just as easy as COP. You just have to remember that rocks are found outside. So that means we're looking outside our table. Okay, and there's nothing outside our table, so we're going to put some stuff outside. Okay, our formula is delta y over delta x. So it starts off the same, but it has this weird delta sign in front of it. Okay, the delta means the change. Okay, and remember we said that it can only be added or subtracted. So delta means that how much are we adding or subtracting. Okay. All right, so when we come over here and look, how do I get from 175 to 250? Okay. Well, first of all, am I
175.
okay? First of all, am I adding or subtracting to get from 175 to 250? I'm adding. Okay. And now you have to figure out how much you added. Okay. So the easy way to do that is to subtract. Think backwards. So you can use your calculator, but I want to know, how do I get from 175 to 250? Plus 75. Good. Thank you. Okay. The next one, 250 to 400. How am I getting from 250 to 400? 150. Good. Thank you. Remember, you can do it backwards if you're not good at thinking forward like that. That's fine. Okay. 400 to 625.
adding 225.
225, okay? Is everybody okay with how I found the outside numbers on this table? Pretty easy, okay? Now we gotta do the x side. How do I get from 1 to 2? Plus 1. How about 2 to 4? Plus 2. 4 to 7?
Plus 3.
Plus 3, okay? So now I'm going to do just like I did on the inside, and I'm going to put the y over the x. So 75 is first, and 1 is first. Okay, the next one is 150 over 150 goes over what? What's my outside number over here?
2.
2.
150 goes over 2?
Yep. And then finally 225 goes over 3. And you might say, oh, those are different. That's okay. We still have to simplify, okay? So now divide our numbers. So 75 over 1 is 75. Okay, what's 150 over 2?
75.
All right, what's 225 over 3? 75. So they all equal 75. So 75 is my rate of change. Okay? 75 is my rate of change. If I have a rate of change, I have a rock. Anybody remember what I said happens if I have a rock?
Outside.
So here we said if we have a rock, it's linear. That means it's going to make a line. So you're going to see these words on your assignment, which is why I'm writing them again, because it's very important. Okay? It has a rock, so it's linear. So if I was to put all these points on a graph, it would make a straight line. Okay? All right, let's do another one. So this time my table looks like this. X goes on top. I have 1 and 4, 2 and 8.
You can't see it.
Oh, sorry. 5 and 20, and 8 and 32. Okay, so remember, rocks are found outside by adding or subtracting. Okay? And I always just start with y so that in my brain, when I go to write it, hopefully I'll remember to do y first. Okay, so how do you get from 4 to 8?
Plus 4.
Plus 4. What about 8 to 20?
Plus 12.
Plus 12. What about 20 to 32?
Plus 12.
Plus 12. Okay, now we got to do the same thing for our x's. 1 to 2.
Plus 1.
Whoops, plus 1. 2 to 5.
Plus 3.
Plus 3. And 5 to 8.
Plus 3.
Plus 3. Okay? Everybody okay with those numbers and where I got them from? Yeah? Okay. So
Yep.
my rock is delta y over delta x. So I'm going to put 4 over 1. And I'm going to put 12 over 3. Now the next one's 12 over 3. Do I need to write that one also? No. Okay, I already have it. So what does 4 over 1 equal?
4.
4. What does 12 over 3 equal?
4.
Okay, so they all equal 4. So my rock is 4. Okay, and if it has a rock, it's also going to be what?
A linear number.
It's going to be linear. Good, thank you. Okay, if it has that rock, it's going to be linear. All right, one more. 1 and 7, 3 and 12, 5 and 14. Okay, so I remember rocks, so I draw my little rocks, my little triangles here. It reminds me I'm looking at the outside numbers. Okay, how do you get from 7 to 12?
Plus 5.
Plus 5. How do I get from 12 to 14?
Plus 2.
Plus 2.
Plus 2. Good. All right, on the top, from 1 to 3. Plus 2. Good. And from 3 to 5? Plus 2. So now I put my y, which is 5, over 2 equals 2 over 2. Is that a true statement? What do I get when I divide 5 by 2?
2.5.
2.5. What do I get when I divide 2 by 2?
1.
So do those equal the same thing?
No.
No. Okay, so there is no rock because they don't equal the same thing. So if there's no rock, it means it is non-linear. Okay, no rock means it's not linear. All right, y'all feel okay about rock? Okay, we're going to go back super quick and check to see if these three now have a cop, just so you don't forget, okay? Cops are putting people where?
Inside.
Inside, so I'm looking at the inside numbers. So we're going to go back to this top one. I'm going to switch colors. My cop, I'm looking at my inside. This is just y over x, okay? So 175 over 1, 250 over 2, 400 over 4, 625 over 7, okay? I know when I divide 175 by 1, I get 175. What is 250 divided by 2?
125.
Okay, do I need to keep going? Are these equal?
No.
Okay, if they're not equal, do I need to keep going?
Yeah.
No, there is no cup. Okay, so because these don't equal each other, there's not a cup. Okay, and if there's no cup, that means it is non-proportional. Any questions on that? All right, we're almost done. Okay, let's do the cup here. Cup is going to be y over x. So I'm looking inside, remember? So 4 over 1, 8 over 2, 20 over 5, 32 over 8. So all I did was I took these numbers and I flipped them, and now I'm going to divide. 4 over 1 is 4. What's 8 over 2? 4. What's 20 over 5?
4.
What's 32 over 8?
4.
4. Okay, so this has a cop, which makes it proportional. Want to make sure you have these notes because it's going to help you with your assignment. Okay, it has a cop, so it's proportional. All of those things simplified to the same thing, so it is proportional. All right, last one. We have y over x, so 7 over 1, 12 over 3. What's 7 over 1?
7.
7. What's 12 over 3? 4. Are those equal?
No.
No, so I don't need to keep going. So this has no cup. So that means it's non-proportional. Okay? All right. If you took these notes, these should be very, very, very helpful notes for your assignment. Okay? We have 30 minutes, which is great because some of the questions are super quick and super short. So most of you will probably be able to either finish or almost finished in 30 minutes, okay? Nobody should have very much homework, if any homework, okay? I am going to ask you to stay on the call in case you have questions. If you're good in about 20 minutes, I'll probably dismiss you, but I do want to keep people on in case I need to ask you questions or you need to ask me, okay? Use your calculator. Use your notes, okay? It is in Schoology day 34. Plenty of time to knock this out, okay? Go ahead and get started. Okay, then I'm just going to make it where